The AMX-30 is a main battle tank designed by Ateliers de Construction d'Isile Moulineaux, AMX, then GIAT, and first delivered to the French Army in 1966. The first 5 tanks were issued to the 501st Regiment de Chars de Combat, Tank Regiment, in August of that year. The production version of the AMX-30 weighed 36 metric tons, 40 short tons, and sacrificed protection for increased mobility. The French believed that it would have required too much armor to protect against the latest anti-tank threats, thereby reducing the tank's maneuverability. Protection, instead, was provided by the speed and the compact dimensions of the vehicle, including a height of 2.28 meters. It had a 105 mm gun, firing a then advanced high-explosive anti-tank warhead known as the Obus-G. The Obus-G used an outer shell, separated from the main charge by ball bearings, to allow the round to be spin stabilized by the gun without affecting the warhead inside. Mobility was provided by the 720 horsepower, 540 kilowatts, HS-110 diesel engine, although the troublesome transmission adversely affected the tank's performance. In 1979, due to issues caused by the transmission, the French Army began to modernize its fleet of tanks to AMX-30B2 standards, which included a new transmission, an improved engine and the introduction of a new fin-stabilized kinetic energy penetrator. Production of the AMX-30 also extended to a number of variants, including the AMX-30D Armored Recovery Vehicle, the AMX-30R Anti-Aircraft Gun System, a bridge layer, the Pluton Tactical Nuclear Missile Launcher and a surface-to-air missile launcher. It was preceded by 2 post-war French medium tank designs. The first, the ARL-44, was an interim tank. Its replacement, the AMX-50, was cancelled in the mid-1950s in favor of adopting the M47 Patton tank. In 1956, the French government entered a cooperative development program with Germany and Italy in an effort to design a standardized tank. Although the 3 nations agreed to a series of specific characteristics that the new tank should have, and both France and Germany began work on distinctive prototypes with the intention of testing them and combining the best of both, the program failed as Germany decided not to adopt the new French 105 mm, 4.1 in, tank gun, and France declared that it would postpone production until 1965. As a result, both nations decided to adopt tanks based on their own prototypes. The German tank became known as the Leopard 1, while the French prototype became the AMX-30. As early as 1969, the AMX-30 and variants were ordered by Greece, soon followed by Spain. In the coming years, the AMX-30 would be exported to Saudi Arabia, Venezuela, Qatar, the United Arab Emirates, Cyprus, and Chile. By the end of production, 3,571 units of AMX-30S and its variants had been manufactured. Both Spain and Venezuela later began extensive modernization programs to extend the life of their vehicles and to bring their tanks up to more modern standards. In the 1991 Gulf War, AMX-30S were deployed by both the French and Qatari armies. Qatari AMX-30S saw action against Iraqi forces at the Battle of Kafji. France and most other nations replaced their AMX-30S with more up-to-date equipment by the end of the 20th century. Background. Although the occupation of France during World War II temporarily interrupted French development of armored fighting vehicles, clandestine research allowed the French to quickly recover lost ground after its liberation in mid-1944. During the occupation, the French had secretly worked on an armor program that was, in 1944, taken over by the State Workshop Atelier de Construction de Rowland, ARL, resulting in the design and production of the ARL-44, which began production in 1946. The tank was powered by a Maybach HL230 575 horsepower, 429 kilowatts, engine, and armed with a 90 mm, 3.5 in, tank gun. Although the 48 metric ton, 53 short ton, vehicle was comparable to contemporary battle tanks in firepower and engine power, it suffered from distinct disadvantages, including an antiquated track design. While 600 were planned, only 60 were ultimately produced by 1950. That year, these were issued to the French Army's 503rd Tank Regiment. Given that the RL-44 had been considered only a stopgap vehicle for the French Army's armored forces since inception, work on a new tank had begun as early as March 1945. Development of the new tank was offered to 5 separate manufacturers: Atelier de Construction d'Oscillating Turret, AMX, Forges et Chantiers de la Méditerranée, FCM, Renault, Société Lorraine de Dietrich, SLD Lorraine, and Société d'Autelage Mécanique et d'Usinage d'Artillerie, SOMUA. The new vehicle was based on the new post-war requirement for a single battle tank. The new vehicle was designated the AMX 50. Its hull and suspension were similar to that of the German Panther tank, which had been used by the French Army in the immediate post-war. The French government's specifications for the new tank were strongly influenced by both the Panther tank and the heavier Tiger I. Specifically, the French Army was looking for a tank with the protection of the former and the firepower of the latter. Although the design borrowed from German tanks, including the Maybach 1000 horsepower, 750 kilowatts, engine, based on an earlier model, and the torsion bar sprung road wheels, the AMX 50 also included a number of unique features. For example, it included an oscillating turret, mounted on trunnions, which was the first of its kind. The oscillating turret consisted of 2 parts, one of which was mounted on the trunnions of the lower part, attached to the turret ring. The main gun was attached to the upper part, facilitating gun elevation and depression, as well as simplifying the fire control equipment and the installation of the automatic loading system. Of the 3 contractors, Renault withdrew from the program, while in early 1946 the French government selected AMX and SOMUA to continue the development. The prototypes were designated M4S, and AMX completed its prototype in 1949, while SOMUA would not be finished until 1956. AMX's first prototype was armed with a 90mm, 3.5 in, cannon, although a second prototype was fitted with a larger 100mm, 3.9 in, gun in July 1950. Although it was intended to put the AMX-50 into production as the standard medium tank of the Western European Union, financial reasons and the arrival of military aid from the United States in the form of 856 M47 Patton tanks caused the original program to be abandoned. In 1951 it was decided to turn the program into a heavy tank project with an even larger 120mm, 4.7 in, tank gun. Though 3 prototypes were built, this too was abandoned in 1956, mainly due to a failure to design a powerful enough engine. With the demise of the 100mm, 3.9 in, AMX-50 program in 1951, France temporarily officially abandoned the thought of producing a medium tank. It was expected that West Germany would soon be allowed to rearm, and the Germans had appeared to entertain the concept of equipping their forces with a host of low-cost light, but relatively powerfully armed tanks, their quantity compensating for a lack of full armament parity with the latest medium tanks. The prospect of delivering many thousands of these to the Germans induced the French to adopt the idea and plan to create light tank Type 67 armored divisions, for which the AMX 13/105 was specially designed. A private enterprise design aimed at fulfilling the same requirement was the somewhat larger Char Bataillons Chatillon. A derived medium tank prototype of the latter, made in 1955, proved that it was possible to produce a tank with a first-rate gun and frontally protected with 80mm, 3.1 in, steel equivalents within a weight constraint of 30 metric tons, 33 short tons. This revived interest in the medium tank concept. In 1956, the WEU Defense Workgroup FINBAL, named after France, Italy, Netherlands, Belgium, and Luxembourg, founded in 1953 and consisting of representatives of the various general staffs, drafted a set of specifications for a new medium tank to eventually replace their American and British tanks. That same year, Germany joined the work group, turning it into FINABEL, the added A standing for Allemagne, Germany in French, and on October 27, 1956 at Colombicher a bilateral agreement was concluded between France and Germany to collaborate in building a tank. Though the other Finabel nations did not formally participate, the type was called Europapanzer to indicate its common European nature, and experts from all countries were involved in the design process. The specifications, Finabel 3A5, for the new tank called for a lightweight and mobile battle tank, setting the weight limit to 30 metric tons, 33 short tons, and compromising the ability to heavily armor the vehicle. French and German engineers, during a conference in Bonn on February 12, 1957, defined the requirements for the future tank. This included a maximum width of 3.15 meters, 10.3 feet, a height of 2.15 meters, 7.1 feet, and a 105 mm, 4.1 in, tank gun, to be developed by the Franco-German Military Research Institute at St. Louis. The new tank would have an air-cooled, petrol engine, a torsion bar suspension with hydraulic shocks, a power-to-weight ratio of at least 30 horsepower, 22 kilowatts, /metric ton, and a road range of at least 350 kilometers, 220 miles. In May, Italy joined the project, though only nominally, without any material contribution, because after the war it had no tank design bureaus. That same year, on November 28, the French and German ministries of defense in Paris agreed upon a contract which would allow both countries to produce two prototypes separately. The next year, however, the project suffered a first setback when Charles de Gaulle took power in France, creating the Fifth Republic. The Paris Treaty had as its main point developing a common nuclear weapon, and on June 17, 1958 de Gaulle decided to refuse Germany and Italy the atomic bomb, to avoid antagonizing the USA and United Kingdom. This made Germany lose much interest in a common tank project also. The French prototypes were developed and produced by the Atelier de Construction d'Issy-les-Moulineaux, under the direction of General Joseph Moligny of the Direction d'études et fabrications d'armements, DEFA, the later Direction technique d'armements terrestres, and AMX head engineer Heisler. The first prototype was completed in September 1960 and tested from February 1961, the second, with an improved rangefinder and track, was tested in July 1961. These first vehicles had a very rounded turret, in a deliberate imitation of the Soviet T-54, and Sofam petrol engines. Another 7, with an improved sleeker turret cast, were manufactured between 1961 and 1963. Work on the German prototypes was carried out by two teams, including Team A composed of Porsche, Maskinen Bockiel, Luther and Jordan and Jung Anthal. Team B was made up by Ruhrstahl, Rheinstahl Hanomag, and Henschel. Wood mock UPS were completed in 1959, while the first two prototypes were finished by 1961, completed by Team A. Development history. De Gaulle decided that France, though formally remaining a member, would no longer participate in the NATO military organization. This caused a rift between France and West Germany, which then started to emphasize standardization with American equipment, especially in armament, and to follow the new NATO policy to use multi-fuel diesel engines. German Defense Minister Franz Josef Strauss began to oppose the common tank project. In July 1963, the Defense Committee of the German Bundesrat decided to procure a purely national tank. In response, the same month the French government decided likewise. Comparative trials were nevertheless held at Mailly-le-Camp, Meppen, Bourges, and Satory between 5 French and 5 German prototypes between August and October 1963, under Italian, Dutch, Belgian and American supervision. The French type had received a separate national designation, AMX 30. The trials indicated that the German type, on October 1 also getting its own name Leopard, had a better mobility and acceleration. The French government decided that it could not procure a new tank until 1965, while the Germans refused to adopt the Franco-German 105 mm, 4.1 in, tank gun, in lieu of the British Royal Ordnance L7, of which they had already ordered 1,500 in the autumn of 1962, their plan having failed for Rheinmetall to produce in Germany a common type of munition of sufficient quality. Suggestions to save the project by combining the French turret with the German chassis failed. As a result, the program was cancelled and the French and Germans definitely decided to adopt their two separate tanks. The prototypes of the AMX-30 weighed 32.5 metric tons, 35.8 short tons, and were compact, with a width of 3.1 meters, 10 feet, comparable only to the Swiss Panzer 61, and a height of 2.28 meters, 7.5 feet, comparable only to the Soviet T-55. In contrast to the AMX-50, the AMX-30 was issued a conventional turret, because it was found that it was more difficult to seal oscillating turrets from radioactive dust and against water when the tank was submerged. Oscillating turrets also had a large ballistic weakness in the area of the skirt and turret ring. Originally, the first two prototypes were powered by a 720 horsepower, 540 kilowatts, spark ignition engine, named the SOFAM 12 GSDS. Later, a multi-fuel diesel engine was adopted, developed by Hispano-Suiza. The 1963 prototypes of the AMX-30 were later rebuilt with the new diesel engine. Two further prototypes, meant to be direct pre-production vehicles, were delivered in November 1965. Besides the diesel engines, they had changed hull and turret casts and different gun mantelets. The latter would again be changed in the production vehicles. The first production versions of the AMX-30, named AMX-30B to distinguish them from the AMX-30A prototypes, were completed in June 1966, manufactured with a welded and cast hull and a fully cast turret. The production version of the tank had a combat weight of 36 metric tons, 40 short tons. The AMX-30's survivability was based on its mobility. French engineers believed that the tank's mobility would have been compromised had they added enough steel plating to protect against modern anti-tank threats, including high-explosive anti-tank warheads, heat. As a result, the type had the thinnest armor of any main battle tank produced at the time. The turret has a maximum armor thickness of 50 mm, 2.0 in, the armor sloped at 70 degrees on the front plate and 23 degrees on the side, offering protection against 20 mm, 0.79 in, armor-piercing projectiles. The line-of-sight armor values are, 79 mm, 3.1 in, for the front of the hull, 59 mm, 2.3 in, for the forward sides of the hull, 30 mm, 1.2 in, for the rear sides and rear of the hull, 15 mm, 0.59 in, for the hull top and bottom, 80.8 mm, 3.18 in, for the turret front, 41.5 mm, 1.63 in, for the turret sides, 50 mm, 2.0 in, for the turret rear and 20 mm, 0.79 in, for the turret top. Further protection is offered by a nuclear, biological, and chemical protection suit, including a ventilation system. One of the unique features of the AMX-30 was the Obus A charge cruise to 105 mm Model F1, Obus G, heat projectile and its main gun, the Model F1, a monoblock steel 105 mm, 4.1 in, cannon. Heat warheads suffer when spin stabilized, a product of rifled barrels, causing the French to develop the Obus G, Gress. This projectile was composed of two major parts, including the outer shell and a suspended inner shell, divided by ball bearings. This allowed the projectile to be spin stabilized, and therefore more accurate than a normal fin stabilized heat round, while the inner shell did not move, allowing the warhead to work at maximum efficiency. The warhead, containing 780 gram hexalite, could penetrate up to 400 mm, 16 in, of steel armor and was effective against tanks at up to 3,000 meters, 3,300 yd. As it combined a good accuracy with a penetration that was independent of range, it has been considered an ideal round for its day. The AMX-30 was also designed to fire the OCC-F1 MLE.60 high explosive projectile, the SCC-F1 training warhead and the OFU-MPH-105 F1 smoke round. The main gun was coupled with a 380mm, 15-in, recoil brake, which had a maximum extension of 400mm, 16-in, and could depress to 8 degrees or elevate to 20 degrees. The turret's firepower was augmented by a coaxial 12.7mm, 0.50-in, M2 Browning machine gun. The tank commander also made use of a 7.62mm, 0.300-in, anti-aircraft machine gun on the turret roof. The vehicle carried 5105mm, 4.1-in, projectiles, 748 12.7mm, 0.50-in, rounds and 2057.62mm, 0.300-in, bullets. The tank commander was issued a cupola which offered 10 all-around direct vision episcopes, and a binocular telescope with 10x magnification. The commander was also given an optical full-field coincidence rangefinder. The gunner was given a telescoping gun sight and 2 observation periscopes. The production version of the AMX-30 was fitted with Hispano-Suiz's HS-110 diesel engine, located in the rear of the hull. The 28.8 liters, 1,760 cu-in, engine could be replaced on the field in 45 minutes, and produced 720 horsepower, 540 kilowatts, offering the tank a maximum velocity of 65 km per hour, 40 miles per hour, on roads. The fuel-efficient engine, in conjunction with a total fuel capacity of 970 liters, 260 US gal, gave the AMX-30 a maximum road range of up to 600 kilometers, 370 miles. The engine's drive is taken through a Gravina G.H.B.200C twin-plate centrifugal clutch. The gearbox was an AMX 5SD 200D, with 5 forward gears and 5 reverse gears. This transmission was heavily influenced by that of the German Panther tank and was based on a project which had begun in 1938. The transmission was one of the AMX-30's major faults and caused a variety of mechanical problems, including that the driver would have to manually change gears at specific times, even if the tank was moving over rough terrain. The tank's weight is distributed over 5 double, aluminum alloy, rubber-tired road wheels on either side, propelled on 570mm, 22-in, wide tracks. The tank could ford 1.3 meter, 1.4 yd, deep water obstacles without preparation, up to 2 meters, 2.2 yd, with minor preparation, and up to 4 meters, 4.4 yd, with full preparation. Full preparation for water operations consisted of the addition of a snorkel tube, the installation of blanking plates, carried on the front of the hull, over the engine compartment's air intake louvers, and the installment of infrared driving equipment, including a searchlight. In 1969 a single special dive training vehicle was adapted, nicknamed the AMX-30 Glout, from French faire gluglu, gurgle, without engine and tracks, that over a ramp could quickly be lowered into a reservoir by a winch. It was equipped with an escape tube. Modernization. During the production run, many improvements were implemented. These included gun stabilization from 1971, and from 1972 replacing the original coaxial heavy machine gun with a dual-purpose 20mm, 0.79-in, autocannon against light armor and helicopters, with the ability to depress to 8 degrees and elevate to 40 degrees. All French Army vehicles were eventually brought to this newer standard. The designation remained AMX-30B. Beginning as early as 1973, only 7 years after the beginning of production, the French began a research program for a future modification of the tank. The project was to result in a AMX-30 Valorise, upgraded AMX-30. In June 1979, the French Army decided to both build new and modernize existing AMX-30s with an improved fire control system and a new transmission, and designated them AMX-30B2S. The first new production vehicles were taken into service in January 1982. Improvements to the Kotak APX M508 fire control system included the installation of a laser rangefinder and a low-light TV, LLTV. The main gun's lethality was improved with the introduction of a new armor-piercing fin-stabilized discarding sabot, APFS. The original engine was exchanged for an improved variant, known as the HS110.2, producing 680 horsepower, 510 kilowatts. The poor transmission was replaced with the semi-automatic SESMENC 200 transmission, now Rank France, with a torque converter. The suspension was improved by adopting new torsion bars and shocks, which increased the vertical deflection range of the road wheels, thereby improving the tank's off-road mobility. From 1998, the French Army started to replace the engines of its remaining AMX-30 tanks and variants with 500 Renault Mach-E 9 750 HP engines. In the 90s, a reactive armor package, named Brennus or Brennus, was developed for the AMX-30B2, but was issued only to 2 tank regiments, which in peacetime were combined into the 1ER/2E chasseurs, that were part of France's Rapid Reaction Force. The other 2 regiments using the AMX-30, the 2E/5E Dragons, only had their tanks adapted for a possible relatively quick upgrade, in case of an emergency. The Brennus system used 112 GIATBS, brick de sur blindage, G2 explosive reactive boxes with a total weight of 1.7 metric tons, 1.9 short tons, offering a protection equivalent to 400 mm, 16 in, of steel at 60 degrees. Recently, the AMX-30 has also been used as a testbed for several stealth technologies, including air cooling of hull surfaces and the use of visual camouflage. This prototype is known as the Demonstrator Furtive au Chenille. Its hull and turret are fully covered by a superstructure built of angled plates made of radar-absorbent material. Variants. The AMX-30 has a number of different variations, including a number of other armored vehicles based on the same chassis. A simplified version of the tank, without the infrared searchlight and periscopes and a less complex commander's cupola, was developed for export, known as the basic AMX-30. This version also came devoid of the pressurized air filtering system, and moved the smaller 7.62 mm, 0.300 in, machine gun into the coaxial position and the larger 12.7 mm, 0.50 in, M2 to the turret roof. Another version was considered for the French Army, adopting a 142 mm, 5.6 in, tank gun able to fire the supersonic ACRA, FR, anti-char rapide autopropulse, anti-tank guided missile, as well as high explosive rounds. A prototype was finished in 1967 with a new cast turret, wide enough to hold the much larger armament. However, the high costs of the missiles forced the French Army to abandon the program in 1972. The vehicles based on the chassis include an armored recovery vehicle, a Brigelier, a self-propelled anti-aircraft vehicle, a tactical nuclear missile launcher and a self-propelled artillery piece. The armored recovery vehicle, known as the AMX-30D, AMX-30D Panzerniveler, was designed to recuperate or help maintain vehicles in the field. Work on the AMX-30D began in 1966, as the French Army researched developing a recovery vehicle to be issued to units receiving the AMX-30 tank. A prototype was produced and delivered for experimentation in 1971, and in February 1973 the first of a pre-series of 5 vehicles was delivered. That same year, another 100 AMX-30DS were ordered, and these began production in 1975. The recovery vehicle includes a winch powered by the vehicle's engine, with the ability to pull a maximum of 35 metric tons, 39 short tons, of weight. The vehicle also has a 80-meter, 87 YD, heavy towing cable, while an auxiliary winch has another 120 meter, 130 yd, towing cable, able to tow up to 20 metric tons, 22 short tons, when working over the front of the AMX 30D. In the latter case, the vehicle must be supported by removable props, which are carried on the vehicle, and the bulldozer blade must be lowered on the ground. The crane can lift up the 3.29 metric tons, 3.63 short tons, power pack and the 10 metric tons, 11 short tons, turret. Instead of a turret, the AMX 30D is fitted with a superstructure, and weighs 36 metric tons, 40 short tons, although with the extra power pack it can weigh up to 40 metric tons, 44 short tons. The vehicle can protect itself with a 7.62 mm, 0.300 in, machine gun. The driver's visibility is aided by the inclusion of 3 M223 episcopes. The AMX 30D has a maximum on-road velocity of 60 km per hour, 37 miles per hour, and a maximum road range of 500 km, 310 miles. The AMX 30 Brigellier, or Poseur de Pont, consists of the AMX 30S chassis with a box-like superstructure, supporting a scissor-type folding bridge. The 22-meter-long, 24 yd, bridge can span 20-meter, 22 yd, gaps. The bridge has a width of 3.1 meters, 3.4 yd, but can be increased to 3.95 meters, 4.32 yd, through the use of applique panels. It can support weighs of up to 46 metric tons, 51 short tons. Brigellier development began as early as 1963, although it was not until June 1967 that development began on a prototype. Although a prototype designated AMX 30H was finished in 1968, it was not until 1971 that the vehicle was evaluated. At the end of the evaluations in September 1971, a pre-series of 5 vehicles was ordered, resulting in a new period of evaluations beginning on October 16, 1972. In 1975, the AMX 30H was declared standard in the French Army, although none of these vehicles were ever ordered. The self-propelled anti-aircraft gun began development in 1969 to provide this type of vehicle to the French Army and for export. Although ultimately none were ordered for France, in 1975 Saudi Arabia ordered an improved version, denominated the AMX 30SA. Developed to defend against low-altitude attacks, the system included 2 Hispano-Suiza 30mm, 1.2 in, 831A automatic guns, coupled to an Urnoir fire control system. This system had already been installed on the AMX 13, in lieu of a heavier chassis, using a turret designated the S401A. Although this particular vehicle began production in 1962, the appearance of the AMX 30 offered a larger chassis to which the S401A turret could be mounted on, providing superior mobility. The heavier AMX 30 also provided a more stable platform for the guns, and allowed the system to carry much more ammunition, 1,200 rounds, as compared to the 600 carried by the AMX 13 version. The guns were designed to fire in 5-round or 15-round bursts, with a cyclic rate of fire of 650 rounds per minute. They were controlled by an analog computer, receiving information from a Doppler radar, which could be folded into an armored box when not in use to protect from damage. The fire control depended on visual tracking, and so could only work in daylight and clear weather. 3 missile systems were developed to be mounted on the AMX 30 chassis. Recognizing the need for tactical nuclear missile mobile launchers, the French Army began developing the Pluton Missile in 1963. In 1964, the program was suspended and instead the French Army opted for a missile with a longer range, able to be mounted on the AMX 30. A contract to develop the system was established in 1968. The first prototype was soon delivered and testing occurred between July and August 1970, followed by the production of a second prototype in 1971. 2 more prototypes were fabricated in 1972. The next year, The vehicle was put into mass production, and by May 1, 1974, 4 of these vehicles had been delivered to the 3rd Artillery Regiment. The missile itself weighs 2.4 metric tons, 2.6 short tons, and is 7.6 meters, 8.3 yd, long. Using a simplified inertial guidance system and a solid propellant rocket motor, the Pluton has a maximum range of 120 kilometers, 75 miles. The second missile system is the AMX-30R, Rowland, surface-to-air missile launching system, which began development in 1974. 5 vehicles of a pre-series were completed by 1977 and then evaluated, prompting the order of 183 vehicles that same year. The Rowland includes a rectangular superstructure, taller than that of both the AMX-30D and the Pluton, which houses the radar system and mounts 2 launching tubes on either side, with an auto-loading system feeding from an 8-missile reserve inside the superstructure. The Rowland's exploration radar has a detection range of 16 kilometers, 9.9 miles. The third missile system, called the AMX-30SA, was developed in 1975 for Saudi Arabia, to fire the SA-10 Shaheen, developed and manufactured by Thomson CSF. The launching vehicle was heavily based on the AMX-30R. The Canon Auto Motor de 155 GCT, for Grande Cadence de Tir, fast rate of fire, was developed based on the AMX-30 chassis to provide tactical artillery support to units in the French army, who refer to it as the AUF-1. The 155 mm, 6.1 in, howitzer was 40 calibers long, and was auto-loaded, allowing it a rate of fire of 8 rounds per minute, with a maximum range of 30 kilometers, 19 miles, with the Lu-211 round. The turret enables the gun to have an elevation of up to 66 degrees, and allows it to traverse a full 360 degrees. The vehicle carries 42 rounds of ammunition, with combustible cartridge cases. The origins of the decision to design a self-propelled howitzer can be traced back to 1969, with the first prototype completed in 1972. By 1979, 7 prototypes had been produced, and 6 pre-series vehicles, followed by the production of 110 vehicles. This order was later increased to 190. The first prototype of an improved AMX-30 for the export market, known as the AMX-32, was unveiled in June 1979. Originally intended as an alternative for the AMX-30.
Please subscribe and thanks for watching.